Dear students, welcome to lecture number 10 of computer graphics. In this lecture, we will discuss rasterization as an application point of view in order to draw various type of primitives such as lines, polygons, triangle, etc. When we use rasterization as an application point of view, then the concept is called raster graphics. So dear students, let's start. Dear student, here is the 2D graphics pipeline which we have discussed in detail in our previous lectures, and it is also known as rendering pipeline. Here in this slide, the concept is once again depicted in a flow diagram in order to recall in your mind. If we focus on the flow diagram, starting from upper left and so on, the first step is object world coordinates that are called 3D coordinates. Then the process of clipping is applied. It is mandatory if the objects are not lie on our view plane. After this process, we have object subset. Then viewport mapping is taken out, which refers to the 2D rectangle used to project the 3D scene to the position of a virtual camera. After that, we have object screen coordinates, which are in 2D form, so as to convert high-level geometry description to pixel colors in the frame buffer for display on the screen, which is actually a rasterization. The whole process that we have discussed is also known as simple 2D drawing pipeline. Dear student, once again I am explaining the concept of rasterization or scan conversion. But this time you should absorb the concept of rasterization as an application point of view. It is used to convert high-level geometry description to pixel colors in the frame buffer. For example, if we have given vertex x, y coordinates, then need to determine pixel colors to draw the line. So there are two ways to create an object or as an image on the screen. Number one is scan existing photograph, and number two is procedurally compute values, which is called rendering. We will discuss the whole raster graphics in terms of rendering. The process is shown in the figure below. All the steps have been already discussed, so there is no need to discuss them further. Here are some important characteristics of rasterization. It is a fundamental computer graphics function. And number two, it is used to determine the pixel color, illumination, texture. Number three, it is implemented by the graphics hardware, that is GPU, etc. And number four, rasterization algorithms are required to draw lines, circles, triangles, polygons. In the later part of this lecture, we will discuss two famous line drawing algorithms in connection with rasterization, that are digital differential analyzer line drawing algorithm and the Brazenham's line drawing algorithm. Important operations of rasterization are: number one, drawing lines on the screen; number two, manipulating pixel maps, pix maps for copying, scaling, rotating and translation, etc. Number three, composition images, defining and modifying regions. Number four, drawing and filling polygons. And finally, the number five, which is very important, aliasing and anti-aliasing methods. As I already told you that we will discuss rasterization process in terms of line drawing algorithms. This could be achieved by few following steps, which are shown on the slides. Number one, programmer specifies x, y values of end pixels. That is, we need to specify the starting and ending of the line in terms of points. Then number 2, we need algorithms to figure out which intermediate pixel are on line path. Here we can use DDA or Bresenham algorithm for drawing the line. Then pixel number 3, pixel XY values constrained to integer values, because number 4, actually computed intermediate line values may be floats. Then number 5, it is required to round them as per requirement. For example, the computed points 10.48, 20.51 rounded to 10, 21. Then at number 6, the rounded pixel values is of actual line path, that is JAGI. JAGI or JAGIs is a term for various kind of anomalies in computer graphics output or displaying imaging, because the shape is displayed with the help of small squares or steps instead of smoothly contoured line. Therefore, at number 7, sloped lines end up having JAGIs or anomaly, whereas at number 8, vertical and horizontal lines have no JAGIs or anomalies. Concept of line drawing in raster graphics is depicted on the slide. Here you can see the grid is arranged in 8 rows and 12 columns. For drawing line, we have specified 2 points, that is starting point and ending point. The starting point of line is 3, 2, which is an intersection of column 3 and row 2, as you can see on the figure in white rectangle. And the ending point is 9, 6, which is an intersection of column 9 and row 6, as you can see on the grid in white rectangle. The arrow is passed from the starting point 3, 2 to the ending point 9, 6 in order to reflect that which intermediate pixels need to be turned on to complete the line in slope form. Hence, this could be achieved with the help of digital differential analyzer or Bresenham algorithms for drawing the line. Before going into further details, it is necessary to understand the drawing of line having slope, that how could we achieve to finalize it. Therefore, luckily in mathematics we have slope intercept line equation, which is y is equal to mx plus b, where m is the slope or the consistent change between 2 points x and y, and b is the y-intercept. Often y-intercept represents the starting point of the equation. We use this equation to calculate the intermediate points in order to complete the line from given starting point to the given ending point. If we have given 2 points x0, y0, that is starting, x1, y1, that is ending, how to compute m and b? Then m is computed taking the derivative of y and x as shown on the slide. M is equal to derivative of y over derivative of x is equal to y1 minus y0 over x1 minus x0, whereas b is equal to y0 minus m into x0. The slope line intercept equation is depicted in the figure below so as to clear the concept in your minds. In this slide, an example is represented in order to calculate or find slope m. That is, if we have 2 points ax comma ay is equal to 23 comma 41, also the starting point of the line and the other point that are the ending point of the line, bx comma by is equal to 125 comma 96. Then we will put these values according to the formula in order to calculate slope m. After completing the computation, we have m is equal to 0.5392, which is the slope of the line. Hence, in this way, we can easily calculate the slope of a line if we have given the points.